Okay. So we've looked at our exponentials with a base. Now we're going to look at our logs with a base. Now here's the thing. There's not a integral that goes with it. There's only a derivative for log with a base. So learn that, love that. The derivative with respect to x of log base b of x is equal to 1 over x natural log of b. Let's talk about this for just a second. What's the derivative of natural log? 1 over x. Now, this is log with a base. You'll just have to tack that additional natural log of b that goes with that base because the base is different. Not a common one, right? Not a common one, but you still need to know it. All right, let's do an example. So here is example 8a. I want to keep that to where we can still, till we can still see it. I want to find this derivative. Find the derivative of f of x is equal to log base 5 of 2x plus 1. Okay, so let's do it right now. My derivative is 1 over the inside. In this instance, it's 2x plus 1 times the natural log of my base. However, because my inside function here requires the chain rule, I need to multiply that by 2 because the derivative of 2x plus 1 is 2. I'm going to scoot this up just a little bit and then just clean it up. F prime of x is now equal to 2 over, and I don't know how you want to write that, natural log of 5 in front or in the back. Frankly, I don't care. As long as you have parentheses around that 2x plus 1, I'm good. Okay. Good job. Good job, good job. Know it and love it. Not a common one, but you need to know it nonetheless. All right? Okay, so in the last section, I teased you with the tower function, and I said in section 7.3, you're going to need to know about the tower function. Welcome, ladies and gentlemen. Here we are. I knew you were waiting for it. Oh, guess what? We're here now. That should make you happy. If I want to take the derivative of, if I have a base, that's a function, and my exponent, that's a function. All right? A function to a function. So it's in the exponential category here, right? But a function to a function, we are going to use b to the x is equal to e to the x natural log of b. We're going to use this because it's using e, which will make our life easier. All right, so see how this plays out. Here's example 6. Scoot this up just a little bit so we can see most of it. We want to, example 6. It has 2 parts, but example 6, I'm given f of x is equal to x to the sine of x. Function as my base, function as my exponent. I'm going to squeeze this in, right? Function as my base, function as my exponent. That is how you identify this. Just by looking at it, I can identify it like that. Now this is my x is my b, my sine of x is the x part. Whenever I look at b to the x is equal to e to the x natural log of b. This is how you assign what is your b and what is your x. All right, so part A here is literally find the derivative. Find f prime of x. That's the first thing we get to do. So I'm going to write this out. If I know that this is x to the sine of x, I'm going to take that b and that x and rewrite this as e, and then the x part is sine x natural log, and my base is an x. Do you see that? This is my x part, and this is my b part. That goes right with that b and that x. Right? Okay. Where this is my base and this is my exponent. Just making sure you get this. It's just rewriting what we already know. We've not done any calculations. We haven't done any calculus, nothing. All we've done so far is rewrite what we know. All right. Now, if I'm going to take the derivative, it's going to be a whole lot easier to look at this and take a derivative because, let me write it over here. F of x is equivalent to e sine x natural log x because it's e, and e is much easier to work with. When I take my derivative here, you keep the exact same thing, e to the sine of x natural log of x, because the derivative of e is e. The key to this is the fact that I'm now going to take this part and we're going to chain. Do the chain rule. That's what's happening here. So when I do the chain rule of this, it is a product rule, right? So the derivative of the first times the second plus the first times the derivative of the second. Chain rule. And that's the key to this. Write it as an e, then chain it. These are equivalent. So when you have this, you want to always go back and write it as what you started with. So this is the same thing as x to the sine of x. Cosine x natural log of x, you can't do anything about that. And I'm okay if you leave this as sine of x over x. I don't care. That's totally fine with me. If you want to factor out that x out of the denominator, you can. You don't have to. I don't care. You could totally leave it like this. All right? You do have to take e back in terms of the original function, but otherwise, just leave it like that. I'm totally down for that. All right? Let me change colors here. Part B says, all right, that's cool. Once we know the derivative, now I want to find f prime of pi over 2. So I'm going to take what my derivative is. So let me scoot it up. I'm going to take my derivative here. Oh, good, plenty of room. And plug that in. F prime of pi over 2 is going to be, everywhere you see an x, you put the pi over 2. Pi over 2 to the sine of pi over 2 times the cosine of pi over 2 times the natural log of pi over 2 plus the sine of pi over 2 all over pi over 2. Lots of pi's over 2 is the moral of that story. So go back to your unit circle. I know pi over 2 is up here and it has a coordinate point of 0, 1. Cosine are the x values, sine are the y values. So this is going to be f prime of pi over 2 equals, if I have anything to the first power, because sine of pi over 2 is 1, that's just going to leave me with pi over 2 as this first part, right? Times the cosine of pi over 2, however, is a 0. So 0 times anything is 0 plus 1 over the pi over 2. Okay, so f prime of pi over 2 is equal to pi over 2 times 2 over pi, because it's the reciprocal. Those cancel. And my final answer is 1. Yes, you're exactly right. All right. So with a tower function, you are going to figure out a function to a function, rewrite it in terms of e, chain that, and then work it out. All right.